Good morning. I am Dr. Huang. Today, I'm going to teach you some skills to calculate heat or enthalpy change for physical and chemical processes. There are three and only three equations to calculate heat for a physical process in Chapter 5. The first equation is Q equal to Cs times m times delta T. The second equation is Q equals Cm times N times delta T. The third equation is Q equals C times delta T. Let me explain each term to you. Q represents the heat. The most commonly used unit for heat is joule or kilojoule. Cs represents the specific heat. It is the heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius or 1 Kelvin. The most commonly used unit for Cs is joule per gram per degree Celsius or joule per gram per Kelvin. M represents the mass of the substance. The most commonly used unit for mass is gram. Delta T represents the temperature change. Delta T can be calculated by using the final temperature minus the initial temperature. The most commonly used unit for delta T is degree Celsius or Kelvin. Cm represents the molar heat capacity. It is the heat required to raise the temperature of 1 mole of a substance by 1 degree Celsius or 1 Kelvin. N represents the moles of the substance. C represents the heat capacity. It is the heat required to raise the temperature of a substance by 1 degree C or 1 Kelvin. There are three different scenarios to calculate the heat for a single chemical process. If you are given the moles of a reactant or a product, you can use equation 1 to calculate the heat. If you are given the mass of a reactant or a product, you can use equation 2 to calculate the heat. The third scenario is a little more complex. If you are given the mass or the moles of 2 or more reactants, then you have to use your calculation to find out which one is the limiting reactant. Then use the mass or the moles of the limiting reactant to calculate the heat. Now let me explain this fraction term, delta H reaction over moles. This fraction term is from a balanced chemical equation. Let me use this equation to explain. Delta H reaction represents the standard enthalpy of reaction. Sometimes enthalpy of reaction is also called heat of reaction. Do not be confused with heat. The symbol to represent heat is Q. The relationship between Q and delta H reaction is like mass and density. The density is the mass for a unit volume, and delta reaction is the enthalpy change or heat exchange when one mole reaction happens. From this chemical equation, 1 mole reaction is equal to 1 mole of C3H8. At the same time, 1 mole reaction is also equal to 5 moles of O2. We can also relate the mole reaction with the product. 1 mole reaction equal to 3 moles of CO2. Or 1 mole reaction equal to 4 moles of H2O. If we treat delta H reaction as one of the products, we can get several relationships which can lead to the fraction terms in our heat calculation equation. 5 moles of O2 is equal to negative 2,220 kilojoules. At the same time, we can say negative 2,220 kilojoules equal to 1 mole of C3H8. At the same time, 4 moles of H2O equal to negative 2,220 kilojoules. Or we can get negative 2,220 kilojoules equal to 3 moles of CO2. Another property of delta H reaction is the value of delta H reaction depends on how the chemical equation is written. If we multiply by 2 for every coefficient, the delta H reaction also needed to multiply by 2. Negative 2, 2, 2, 0 multiplied by 2.